So in this video we're going to look at basic trigonometry. We're going to look to find a side in a right angled triangle. Now the first thing to note is if you have been given two sides, so for example this one, and you're looking to find the third side, the missing side, this one in a right angled triangle, then all you need to use is Pythagoras. We use trigonometry when we have got one side and an angle, or we've got two sides and are looking for an angle. Before we can start on the problem, we have to label the diagram. There's a couple of things you know straight away. You know that the longest side is the hypotenuse, and hopefully you know that the hypotenuse is always opposite the right angle. So we can label that one H. All you have to do now is decide on which one of these is the opposite and which one is the adjacent. The way we do that is we use the angle that you've either got or the angle you're looking for. So this is the angle there. If you imagine that that is an eye, here's your eyebrows. Okay, you are looking across and you are looking at the opposite side. So that one is your opposite. We'll label that one O. Therefore, the last one is the adjacent side. Okay then, let's set up a problem and have a go. So in this question we've been given an angle here of 32, a side of 8, and we're asked to find side x. Now the first thing we do is label the diagram. So again, opposite the right angle is the hypotenuse. Opposite this angle here, the one we've got going across, that's our opposite side. And finally that leaves our adjacent, which is equal to 8. So now we've done that, we need to write out SOH CAH TOA. SOH CAH TOA is just a way of helping us work out which function we're going to use. So now we've got SOH CAH TOA written down, we look at what we've got and what we're looking for. We have got the adjacent side, so if I underline the A, and we want the opposite side, so I underline the O. Now it's the one we've got two parts of that we use, so you can see we're going to use something called TOA. TOA just represents this formula here, the tan of the angle theta, which is equal to the opposite side over the adjacent side. Now we've got this formula, all we do is substitute the values in. Well, theta was 32, so I've got tan of 32 degrees is equal to the opposite. Well, the opposite is known as x, so I'll put in the x in there, and the adjacent was 8. So now I've got this formula, I can solve it. So all I need to do is rearrange to find x. So if I multiply both sides by 8, x is equal to 8 times the tan of 32 degrees. So all I do now is put that in my calculator to get the value. So I actually get 4.9989. So if I round that up to one decimal point, that will be 5.0 centimetres. Let's look at another problem. So in this question we've been given the angle, we've been given this side here which is the hypotenuse, and we've been given this side here which is the adjacent. So let's label this up. We know the hypotenuse is opposite the right angle. If I look across, that side is the opposite, which means that this side is the adjacent. So again I write out SOH CAH TOA just like I did last time. And I establish which function I'm going to use. So I have got, in this case here, I have got the hypotenuse and I want the adjacent. So I underline those. I've got the hypotenuse and I want the adjacent. So you can see in this case I'm using the cos rule. So we write this one out. Notice its structure is exactly the same as the tan. So where we had tan theta equals opposite over adjacent, now we've got cos theta is equal to the adjacent over the hypotenuse. So the setup is exactly the same. All we do now is substitute the values. Theta is 18, so the cos of 18 degrees is equal to the adjacent, which is x, over the hypotenuse, which is 12. We rearrange that for x. X is now equal to 12 times the cosine of 18. So therefore x is equal to, and again we'll put that into our calculator. And that is 11.4 to 1 decimal place. Now hopefully you can see that the steps and the layout is the same. So first of all, step number 1 is to label the diagram. Step number 2 is to write out SOH CAH TOA, and step number 3 is to write the function out properly, and then finally substitute and solve. Okay then, so one final question. So here goes then. So step 1, label the diagram. Here is the hypotenuse. That one there is the opposite, and therefore that's the adjacent. Step 2 is to write out SOH CAH TOA. And then identify what you've got and what you're looking for. So in this case, we have got the opposite, and we're looking for the hypotenuse. So now we underline H and O, so there's the O and the H. Clearly we can see it is the sin theta function, so we just write that out. Again, it's exactly the same format as before. So you've now got the sin of theta is equal to the opposite over the hypotenuse. Hopefully you can recognise that each of those are written in the same way. Sin of theta, side over side. Cos of theta, side over side. Tan of theta, side over side. So once you've learnt one structure, the rest of them are the same. So step 3 is to substitute in the values. So in this case, we've got the sin of 56 is equal to the opposite, which is 27, over the hypotenuse, which is x. Now notice in this case, the x is as a denominator. So when we rearrange this, you must make sure that the x becomes a numerator. So therefore, x is equal to 27 over the sin of 56. Now again, you just put this in your calculator. So therefore, x is equal to, and our answer is 32.6 to 1 decimal place. 32.6 centimetres to 1 dp. Now, one of the things you ought to do on all of your questions is to decide whether you think the answer is sensible. So in this case, this x is the hypotenuse, which is this side here. Now we know that hypotenuse should be longer than the other two sides. Well, we haven't got the adjacent, so we can't check that. But actually, 32.6 is longer than 27, therefore that seems like a sensible answer. Always worth that check.